So the fault tree solution includes 35 blocks between events and gates. So it's actually more complex than we have imagined. So we only had 8 spokes for our wheel. And what we do, we divide it into 2 sections because we've got to satisfy 2 independent conditions. The first one is we cannot have failure of 2 adjacent spokes. And this is done by a set of AND gate. We have 8 AND gate, and each one has 2 spokes as a base event. In the first one we have spoke A and spoke B. In the second one we have spoke B and spoke C. In the third one C and D, and so on. And in the last one we have H and A, because we've done the full turn of the wheel. But we only got 8 spokes, so we make a full use of mirror block. We introduce mirror block at video number 10, and you can check it out on that video, the concept of mirror block. But essentially we are taking, say in this case, spoke B, and we are reflecting the image of that B onto the next AND gate. So the next one will be made of spoke B, which is reflected, and spoke C. And the next one will be made of spoke C, that is reflected, and spoke D, and so on. So in reality, we only have 8 spokes. But for the first condition, we end up satisfying this condition with a set of 8 AND gate and 16 spokes. Then the second part of the problem is we cannot have more than 4 failures. So we are allowed to have failure on non-adjacent spokes, but we cannot exceed more than 4. I mean, it is quite dramatic anyway. And we can do that, we can achieve that via a voting gate. And on the voting gate, we set the criteria that will make our voting gate activate. So we have base event, we have 8 spokes as a base event, which again are mirror from the original 8. So in total, we have 24 spokes, but the original number is only 8. All the others are mirror. They are not copies, they are actually mirror, they are a reflection of the original 8 events. And here, as we say, we set the condition of 5 spokes that will invalidate or will break, if we want, our wheel. And the next thing, we've got to test this condition. So we are on this part of the fault tree, we can test that. So we can say we are allowed 4 failure, so we set A to fail, and we can see that that is reflected also on the previous AND gate and also on the very first AND gate, because it is actually a mirror image of that. So we break spoke A, and also we are not allowed to break the adjacent one, so we break C, and we break E, and we break G. So we've broken 4 spokes, and now we can test it. We can test it, and we have a result, and we have a result of the top event. The top event is made out of the OR gate of these 2 conditions. Either failed the 2 adjacent or failed the condition of more than 4 spokes. So we haven't satisfied either of them, and our wheel is still functioning. So we can take this failure out, or if we add an next failure, then it fails for both conditions, because now we got adjacent condition, and also we fail 5 times. So we can see that now we'll invalidate this AND gate, and this OR one will give us a result of 0, and the top event will be 0. But we can test finally the condition of 2 adjacent failure by taking all the others out. So we only got 2 failures, and failure of spokes A and B. Obviously this condition is not satisfied, so we'll have the results going through, and we can see that with a number, but we won't have satisfied the condition of failing on 2 adjacent spokes, and as a result of that we'll have this condition of the OR gate equal to 0, which will then reflect at the top event. So in this video we looked at the fault tree condition. In the next video we'll be exploring the RBD condition.